Hello, welcome to the channel. So, in this video, we'll discuss about the availability types of GKE. So, basically, availability types refers to availability of the cluster components. Like, for example, the availability of control plane and the node pools, right? So basically, we'll see the options how you can configure high availability for control plane components and also for uh, the worker node uh, set of thing, right? Uh, so let's proceed with this. So yeah, moving to the next first slide. So basically, these are the cluster availability types in GKE, right? So, in broad, there are two types. One is zonal cluster and another is regional cluster. So, within zonal clusters, you have single zone cluster and also multi-zone cluster. So, these are the availability types for GKE. So, we'll in the further slides, we'll go through in detail for over each of this availability types, and we'll see what are the benefits and limitations for each of this availability types of GKE. So one thing to note is that after you create a cluster, like whether you create a single zone, multi-zone, or a regional cluster, you can't convert them from uh, regional to zonal or zonal to regional, right? So there is no options to convert the cluster uh, type. In both cases, you can't convert them to the other availability type once you have the cluster created. So, right. So, uh, yeah. So, single zone cluster and multi zone cluster, you can have them uh, converted like kind of the single zone or multi zone cluster. The difference is mainly based on the node pool availability type. So basically, you can have this conversion, but you can't have zonal to regional cluster conversion. So moving on to the next slide. So we have single zonal cluster. So what does a single zonal cluster mean? So basically, a single zonal cluster is nothing but the control plane will be having only one replica and in a single zone. So, for example, if you create the cluster in US Central 1 region and you choose the control plane availability zone to be US Central 1A, and yeah, so that basically means that you are creating a single zone cluster and you will have uh, the control plane replica only available in US Central 1A, and uh, that's only one replica. So, only one instance of control plane will be available for you as part of the sys configuration. So another thing is single zone cluster manages workloads on nodes or node pools running in the same zone. So if you are creating a single zone cluster, then your node pools should be created in the same zone as well, right? So it will be hosted in the same zone as well. So uh, you can have number of nodes as part of the node pool, but everything, all the node gets created in the same availability zone. The other thing is this setup is more suitable for development and testing workloads where availability isn't a major concern. So for testing a development environment, we can have some downtimes. For example, when there is a uh, cluster upgrade scheduled for the cluster, or if in case there is some maintenance event scheduled for the compute resources or any other resources that uh, helps you create a cluster, right? So uh, those times the cluster availability will be affected. So these outages we should be able to handle when the environment hosted on the cluster is used for development and testing purpose, right? So that's basically better to have only development and testing workloads hosted on the single zone cluster due to the uh, availability type of the cluster, right? So moving to the next slide, the benefits of zonal cluster, single zone cluster. So what are the benefits of using a single zone cluster? So the single zone cluster, it helps you with lower cloud costs, right? So you don't have to pay more since you are not having a high availability setup for your cluster. You don't have to pay more uh, as part of the cloud cost, and also the resource utilization will be less, right? So since you are not putting multiple availability cases for your cluster, you won't be using multiple VM instances or any other resource types, right? You won't have any high availability configured. So that way you are only using a lesser number of components, cloud resources, and you are incurring only lesser amount of cost for the same. Right. So the next thing is easier setup and maintenance. A single zone cluster is easy to configure and easy to maintain as well. You are not handling a lot of additional configuration that comes in as part of enabling high availability for your cluster. So that's, yeah, it helps you with easier setup and maintenance of the cluster. Right. The next thing is it's easy. You will have a faster deployment and you will have scaling with reduced complexity. Right. So what do we mean faster deployment is in case you are having any ad hoc clusters being created to run any of your workloads, you spin up a new cluster, you perform any ETL kind of job, or run any batch processes in Kubernetes, right? So that times, if in case you would like to create a GKE cluster and then have the job run completed on the cluster, and then you would like to grab the cluster after that, uh, you can use a single zone cluster, which is pretty straightforward to create. You don't have to handle additional configurations, and also scaling. It's reduced complexity, right? Because you are handling only one zone uh, for the as part of the node pool, right? You are not having node pools across zones, and you will have to make sure you have a balanced spread of the nodes across the zones, and those additional overheads you are not encountering here. So that's what we mean faster deployment and scaling with reduced complexity, right? So and also the architecture is a simplified one, uh, wherein it's not a complex architecture where you would have to have your control plane hosted and made available in multiple zones, or your node pools spread across multiple zones to handle zonal outages, right? So you are not handling those kind of complex architecture stuffs when you are architecting anything, any workload or application hosted on a single zone cluster. It's easy for you to architect the environment as well. So moving to the next slide, which is limitations of single zone cluster. So when you have a single zone cluster created for hosting your workloads, you will have to understand that these will be the limitations that come in with this single zone cluster. The first thing is there will be a complete cluster outage during zonal outages and maintenance events, right? So whenever there is a any kind of outage going in a specific zone, for example, US Central A, where your cluster might be hosted, there is a networking outage or any storage level failure or compute resource failures, those times your cluster will have a complete outage as well, because all your compute, storage, and networking resources are local to that zone, and whatever happens when there is an outage to the zone, you will have a complete cluster outage. That means for your control plane and also your workloads as well. And in case of maintenance events as well, if there is any emergency maintenance events or scheduled events, you will have outage according to the nature of the maintenance event, right? So you might have cluster outages. So that's one of the main limitation. The other limitation is that single zone cluster, you can't host your mission critical applications. Mission critical applications means your production workload or SLA bound workloads, wherein you have to make sure the services have their minimum availability maintained as part of the service level agreement, right? So that's another limitation here. And the next limitation is scalability constraints due to presence in single zone. So what do we mean here is that so let's say you have node pool created of certain compute type, like for example E2, standard, medium, or any type of compute resource type, right? So if in case there is any resource constraints, like in case Google don't have any additional compute power to provision to your request, those times you won't be able to scale your cluster, right? Since you are only hosted on a single zone where Google doesn't have any other any further compute resource for the specific type of compute family you are using, you won't get any additional compute instances. So at that time you won't be able to scale your workloads that's part of this cluster, right? So you will be having such limitations as well if in case if in case Google Cloud has any usage levels that are at saturation and they don't have any further compute to allocate to your additional compute provisioning request, right? So that's another limitation for a single zonal cluster, right? Moving to the next one, talking about what is a multi-zonal cluster, right? So what are the features of a multi-zonal cluster? So similar to a single zonal cluster, you will have only one replica of a single replica of a control plane in a single zone. Even you create a multi-zonal cluster, right? So where the difference between the single zone and multi-zone cluster comes in is you will have your node pools running across multiple zones, rather than the control plane is posted in only one availability zone, and a single replica will be there, but your worker nodes, the node pools that you create to as part of the worker nodes, right? The worker, the data plane that will be spread across the multiple zones in the region where the control plane is hosted. So the limitation is that wherever you create your control plane, for example, you create your control plane in US Central 1A, then the node pool regions can only be uh, the node pool availability zone choices can only be made within this zone. For example, US Central 1A, 1B, 1C, 1D, whatever the zones available in that region, only those zones you can choose to host your node pools. You can go outside of the region where the control plane is hosted, right? That limitation is there. So that's what you call as a multi-zonal cluster, single replica of control plane and node pool spread across multiple availability zones, right? So the next thing is you have the flexibility to choose the node pool hosting across multiple zones or to a single zone at a node pool specific configuration as per the requirement. So what I mean here is, let's say you have four node pools that's part of your multi-zonal cluster, and you can have two node pools created as a multi-zone hosted node pool, and another two zones if you have any specific requirement to host uh, put it only on a single zone, you can do that as well, wherein you don't need any high availability for the workloads that's hosted on this two the third and fourth the node pool. You don't have to have that node pools hosted across multiple zones. You can host it in a single zone. So you can mix the node pool hosting as well, multiple zones and single zone as part of your multi-zonal cluster configuration. Right. So so the next thing is the multi-zonal clusters are mostly suitable for hosting staging or pre-prod environments where control plane availability and a minimal outage to workloads isn't a major concern, right? So, for example, let's say in a multi-zonal cluster case use case, you have a zonal outage where you hosted your control plane, right? So your control plane won't be available, and the workloads that were hosted on the node pools where whose nodes are hosted on this particular availability zone, let's say US 1A, won't be available. But workloads that are currently running on uh, the other availability zones as part of the node pools, those will still be available, and those services will still be serving your traffic, or you can access that service, right? So that service is not completely down, it is still available. It's just that your control plane and some of the nodes are down due to uh, the zonal outage or any maintenance event that happens local to that availability zone, right? The that's a benefit of the multi-zonal cluster. Right. Moving to the next slide, which is the benefits of multi-zonal cluster. So one of the benefit is that you get enhanced workload availabilities during the zonal outages, as I mentioned previously, right? So if there is a zonal outage wherein your workload is hosted and you have the workload deployed in a multi-zone configured notebook, then whichever regions does it, have any outage, those regions will sorry, those zones will still be able to serve the requests or traffic, incoming traffic that's uh, targeted to the workloads deployed over there, right? So that's an benefit of the multi-zonal cluster on over the single zonal cluster. So the multi-zonal cluster provides a balance of availability and cloud costs, right? Uh, for your requirements, like for example, as I mentioned, you can have your staging or pre-prod environments hosted on a multi-zonal cluster. So there, it won't be much of a necessity based on your requirement. If uh, based on your requirement, if you don't have to have the control plane availability at all the times for your staging or a pre-prod cluster or any cluster, right? You can choose multi-zonal cluster, right? So you are not incurring additional costs for having your control plane available at all times by having additional replicas. You are saving some money there, compromising a minimum downtime or availability of your control plane, but still you are having high availability setup for your workloads, wherein the workloads are not going to be down if there, even if there is a zonal outage. uh, as, in one of the zones that you have created your control plane and node pools, right? So that way you are saving some costs. You are having high availability as well, right? So that's where multi-zonal cluster provides you a perfect provides you a balance of availability and cloud costs, right? So the next thing is addresses zonal level resource availability concerns, right? So at this point we talked in the single zonal cluster, wherein if you are using a specific compute family for your node pool and Google Cloud uh, had saturated its resources available for that specific compute family, then being hosted in that specific zone, you won't be able to scale your workloads, right? So in this case, wherein you have multi-zonal cluster, uh, having a multi-zone configured node pool, when there is this issue happening in one zone, right? Let's say in US Central 1A, you won't have any, you don't have, Google doesn't have any additional compute resources for the compute family you are using for this node pool. You can still scale your workloads by placing them in the other availability zones that's the where you had your resources created, right? So that's another benefit of having a multi-zonal cluster. And the next thing is idle for workloads with variable demands, right? So here we are talking about the same thing, right? The availability concern, the compute availability or any other the storage availability, right? So having multi-zonal cluster, even if in one zone you don't have that additional resources available for your scaling demands, you can still have that scaling happening in the other additional zones where you have configured your node pool, right? There you can have the additional resources created and then you can scale your workload. So that's where you get the benefit of having workloads with variable demands hosted on the multi-zonal cluster. All right. So going to the next slide, limitations of multi-zonal cluster. Right. So what are the limitations of a multi-zonal clusters? The multi-zonal cluster will still have reduced control plane availability during zonal outages and maintenance events. So basically means your control plane, if that availability zone where you hosted the control plane is having any zonal outage or maintenance events, your control plane won't be available, right? So that's still a limitation in the multi-zonal cluster. And the next thing is cross zone traffic costs, right? So when you deploy your uh, node pools, the worker nodes across uh, multiple zones, what happens is when your workloads talk from different zones, communicate with each other, there is uh, traffic getting transferred between zones, right? So basically Google charges for interzone traffic, network traffic, so there is some minimum costs for that. So you will be incurring that additional costs by hosting the node pools across different availability zones, right? So that's an additional limitation. This will be a big, I mean, this is the main thing to consider if you are having workloads that transfer huge data between the instances of that service, right? For example, between parts of the service, there is a lot of traffic movement happening. Then at that times, you might incur this cost to an noticeable value, right? So that's what it is. So the next thing is increased operational maintenance due to distributed workloads, right? So if you are putting your workloads on a single zonal cluster, you don't have to worry about making sure to uh, have your workload spread evenly across the availability zones, node pools availability zones, right? To make sure that your workload is always available even though there is a zonal outage, right? So you have to do some additional configurations for your workload to make sure that your workload gets spread across these availability zones, right? So there are certain node affinity and topology configurations that you need to take care of at the Kubernetes manifest level to make sure that your workloads get spread across the availability zones so that you don't get to face any downtimes during a zonal outage or maintenance events in a specific zone, right? So that's an additional limitation wherein your wherein you incur additional operational overhead, right? So that's another limitation with the multi-zonal cluster. Moving to the next slide. So regional cluster. So what are the features of the regional cluster, right? So with regional clusters, you get uh, multiple replicas of control plane across availability zones in a single region. By Google by default maintains three replicas of control plane in three availability zones, right? A total of three in three availability zones. So, for example, if you create your regional cluster in US Central 1 region, then Google might choose US Central 1A, 1B, 1C to host your control planes so that even during zonal outages, your control plane is available for you to make any request to the Kubernetes clusters API endpoint, scale your workload, scale down your workloads if you are doing any manual scale up, scale down, and also deploy any workloads for your cluster or make any changes to the cluster configuration during any of the region outages, right? So so that we mainly choose the regional cluster. That's why Google has this availability type made available, right? To have higher availability for your control plane, unlike the zonal clusters, right? So the next thing is this is more or less similar to the multi-zonal cluster. Manages workloads on nodes or node pools running in multiple zones in the region where the control plane is hosted. So, as we discussed in the multi-zonal cluster, you can create your node pools in a single zone or on multiple zones in the region where your control plane is hosted, right? So that option uh, it's part of the regional cluster as well. And the next thing is by default, GKE replicates the node pools across three zones of the control planes region. So I'll show this what I mean here in the console itself at the end of the video. So what I mean here is that uh, if you if you create a regional cluster and when you create a node pool, by default Google enables three availability zones for this node pool but this is by default without you manually going in and customizing the configuration. By default, it chooses the uh, three availability zones where your control plane is hosted, right? So you still have the option to choose a specific availability zone from the region where your control plane is hosted. You can go with the default option, or you can still customize the availability zones for your node pool, or you can uh, limit the uh, node pools to a single zone wherein you have uh, a certain use case where you don't need have a high availability for a specific type of production workload. For example, if you would like to uh, uh, run a job to clean up any cache files or clean up any storage, right? You might not need that much of availability for that workload. You can take a minimal amount of downtime, zonal downtime, wherein the zonal outage happens. It's not like a mission critical thing that needs to be run in production, right? So those kind of things you can put this uh, on a single zonal node pool as part of the regional cluster, right? So that's what we mean here. And the next thing is flexibility to choose the node pool hosting across multiple zones or to a single zone as per the requirement. Yeah, that's what I explained now, right? So most suitable for production environments where control plane and workload availability is of major requirements, right? So why do you choose the regional cluster? Is that you need high availability at all times, even during any maintenance events in a uh, specific availability zone or a zonal outage. You need your cluster to be available, control plane to be available for you to make any changes to the cluster configuration, workload configuration, and also the workload availability is a major requirement, right? And so your regional cluster provides you with that options, right? So moving to the next slide, the benefits of uh, regional cluster, right? So what are the benefits of having a regional cluster created, right? So you get high availability for both your control planes and workload during zonal outage and maintenance events. So as we discussed, you get high availability for both your control plane and also your worker nodes or workloads or data plane, whatever you call it, right? So you get that additional high availability with the regional cluster. And the next thing is it's ideal for mission critical applications maintained under service level agreement, right? For example, uh, you have a production environment which is bound under a service level agreement wherein you have to provide the customers with the 99.99%, whatever the number of clients availability you have to provide uh, to the customer, right? So those kind of use cases, you can have your workloads deployed in a regional cluster so that at all times your applications are up and running and available even during a specific zonal outages and uh, maintenance events, right? So that's what I mentioned here. And the next thing, enhanced availability for compute resource across zones. This we already discussed in the multi-zonal cluster, wherein you have any compute resource availability shortages in a specific zone, because in cases where in Google Cloud might have saturated their resource availability for that specific compute family, you can scale your workloads by creating the resources in the other regions where your node pool can create these resources, right? So that's another benefit of the regional cluster. Moving to the next slide, which is the limitations of regional cluster. So it's not kind of a limitation, it's kind of main thing to note, or a concern you might have to address while you choose the regional cluster, right? So with regional cluster, you might have to incur higher cloud costs due to cross-zone traffic and additional control plane replicas, which helps you with having your control plane availability, right? So earlier in the zonal cluster types, you have only one replica per control plane, so you only pay for that. But here you have by default you have three replicas for the control plane, so that means you have to pay two times more money than what you have been pay for what you will pay for a zonal cluster, right? So you will get higher cloud class, including the cross zone traffic that we discussed in the multi-zone cluster limitations, right? So when traffic flows from one zone to another zone between the workload pods, you have to pay for that, as Google charges. Most of the cloud provider charges for inter-zone traffic, right? So that cost also adds up here in your regional cluster usage. And the next thing is the complexity with configuration of workloads and other resources like networking, node pools, etc. Right? Uh, so basically, the complexity that this we already discussed in the multi-zonal cluster, wherein you have to make sure that the workloads that you deploy on the multi-zonal node pool, you have to make sure that the workload is distributed across the availability zones, right? To make sure that the service availability is there even when there is a zonal outage. So these are some additional complex configurations you might have to handle in the Kubernetes manifest as part of choosing the regional cluster, and to have availability for your high availability for your services, right? And also there are other resources you might have to configure, like networking resources and additional node pool configurations you might have to uh, configure as part of your high availability configuration, right? These are some additional operational overheads and challenges you might face when you choose the regional cluster. The next thing is maintenance overhead while ensuring SLA, right? So even though you choose a regional cluster, you need to have some control over the maintenance activities that Google performs on the regional cluster, right? For example, let's say you might have to upgrade your GKE version, the underlying Kubernetes version, right? So those version upgrades you might have to properly coordinate and schedule maintenance windows so that you have a controlled rolled out of the upgrades, and then you can make sure that the upgrade doesn't break anything uh, before the services become available for consumption, right? So those kind of scenarios you will have to make sure that you plan the maintenance window properly, ensure that your cluster upgrade goes in properly, and post upgrade everything works, and those kind of additional stuffs that comes as part of the SLA, wherein you have to make sure to have things planned accordingly to make sure that your services are available as per the SLA terms, right? So that's another limitation. Uh, the additional the setups that you have to do for this coordinate the effective rollout of upgrades and stuff, that's a limitation with the regional cluster as well. So moving to the next slide. So I have created a uh, comparison table here. So like here you have all this comparison over the single zonal, multi-zonal, and regional cluster over the features available in GKE, right? So this we have already discussed. I thought putting it in a table will be easier for everyone to refer it over a glance. So let's go feature by feature. So control plane availability, right? So control plane availability for a single zone cluster is low, and also multi-zone cluster is low because you have only single replica for single zone and multi-zonal clusters. But for regional cluster, the control plane availability is high because we have three replicas spread over three availability zones to make sure the control plane is highly available, right? So moving to the next thing, control plane replication. So control plane replication, as I mentioned, for a single zone cluster, it is only the control plane replica is only available in one availability zone, and multi-zonal cluster also has control plane replica available only in one availability zone. And regional cluster, it has multiple replicas available in multiple zones, right? By default, three zones. That's what GKE maintains. And how the workload availability is across the availability types is that with single zone cluster, the workload availability is low. You have one the node pool is only created in a single zone, so during the zonal outages you don't have any way the workloads will be down as well. You won't be able to reach the services, right? So access the services. So workload availability for single zone is low. Multi-zonal is high because you can have your workloads spread across multiple availability zones based on your needs. So workload availability for multi-zonal is high, and also regional cluster is also same. Yes, you can have high availability for your workloads uh, as part of the design. So moving to the next thing, the workload fault tolerance. Workload fault tolerance is limited to a single zone in a zonal cluster. As you know, the node pools are hosted in a single the same zone where the control plane is. And multi-zonal cluster, you can have single or multiple zones. You can configure it. And also the regional cluster as well, you can have multiple zones, by default 3 zones, or you can configure the workload fault tolerance based on your requirement. And cost. So cost is low for a single zonal cluster because you don't have high availability uh, included for your control plane and the workloads deployed on the cluster. For a multi-zonal cluster, it is medium because for control plane you don't have high availability, but for your workloads you can have high availability configured. So cost is medium, and for regional cluster the cost is high. You have high availability configured for both your control plane and also your workloads deployed on the cluster. So the cost incurred is highest out of all these three for the regional cluster. So operational overhead or configuration overhead, as we discussed. So for a single zone cluster, you don't have to put in any much additional configurations for your workload level or cluster configuration level. So the overhead is low. For multi-zonal clusters, it's medium because you will have to configure your workload availability and node pool availability by configure it in multiple zones. So the overhead is medium. For regional, it is high. You have to configure high availability for your control plane and also the workloads, and you have to you might have to end up in handling the schedules for your cluster upgrades or any maintenance events over the cluster, right? So the overhead for regional cluster is high. So the ideal use case for this cluster, single zone cluster, can be used for development and testing environment, wherein you can uh, have any acceptable downtimes for your workloads and also the control plane. For multi-zonal cluster, the ideal use case is for staging or pre-prod environment where you will have uh, high availability for your workloads. Your services will be available uh, at most, and but your control plane can be down, which you can handle. Uh, can take a minimal downtime for it since it's not a SLA bound environments, right? So, and regional cluster ideal use case is for production or an SLA bound environment, whether you have a non-prod environment which is bound under SLA as well. So those cases you can, and for production mission critical applications, you can have regional clusters used for it, right? So yeah, that's pretty much here. So I'll come out of the slideshow and then I'll move to the Google Cloud Console. I'll provide you a brief overview of the configuration, right? Where to and how to configure your uh, GKE cluster configurations to have a zonal or regional cluster creation, right? So here we are in the standard cluster creation page. So the location type, you have if you are going to create a single zonal cluster, you have to choose it as zonal and then choose whichever zone you would like to create the control plane in, right? So the cluster one. So I'm gonna choose US Central 1A, and I'm gonna skip all this thing, go to the node pool. So here you have the node pool configurations. So here, as you can see, by default, what Google does is by default. for a single for a zonal cluster, you will have the node pool as well created in the same availability zone where your control plane is. So that means if you proceed with this configuration, you will be having a single zonal cluster. To have a multi-zonal cluster, what you have to do is you have to choose the specified node locations option, and then you have to choose the further availability zones that you would like to have for the node pool, the specific node pool. You can have the node pool nodes created in additional availability zones, right? So as you choose it, here you can see the number of nodes changes to per zone. If you don't choose any additional zones, the total number of nodes will be specific to this availability zone. If you choose additional zones, then this number gets counted per zone level. So three nodes for three zones, you will get 9 nodes. So if in case you are putting uh, creating a node pool in multiple availability zones, make a note of it. You have to adjust this number so that by default you don't have a lot of nodes running as part of the cluster and incurring more costs, right? So move back to the cluster basics configuration, and then I'll show you for how to create the regional cluster. For regional cluster, you have to choose this option and then choose the region where you would like to create the cluster in. So I'm gonna choose US Central 1, and so here if you uncheck this by default, the default option what you can see is by default Google puts your node pool in 3 zones from US Central 1. So basically, Google chooses the availability zones in the backend for your cluster. That's the default option. So if you would like to specify the node locations manually, you can choose this option and you can customize as per your need. You can have your nodes scheduled in all the availability zones, or you can uncheck the default zone, which is US Central 1B, which was selected earlier, and you can put it in the rest of the 3 zones. Or you can also uncheck the other availability zones, and you can have your node pool hosted in only one availability zone as well. So you have multiple mix match options when you create a regional cluster, right? So this is how you create a you choose the configurations to create a single zone cluster or a multi-zone cluster or a regional cluster, right? So that's pretty much about the availability types in GKE. So with this, I'll conclude this video. Thank you for your time.